Hi everyone. Today we'll be discussing the LeetCode problem of the day, minimum number of operations to make all array elements equal to 1. So here you are given a 0 indexed array nums consisting only positive integers. And you can do the following operation any number of times. So the operation is you can select any integer I such that I is from 0 to n minus 1 and replace either nums of I or nums of I plus 1 with their GCD value. You have to return the minimum number of operations to make all the elements in the array equal to 1. And if it's impossible to do so, you have to return minus 1. And the GCD of two integers is the greatest common divisor of the two integers. So let's look at the first input. We have 2, 6, 3, and 4. So in first operation, he's selecting these two numbers, and GCD of these two numbers is 1. So that one you can either replace with this value or this value. So in the input, he's replacing this 3 with 1. So you have used one operation. And in the second operation, he's picking these two numbers and their GCD is 1. So he's replacing this 6 with 1. And in the third operation, he's picking these two numbers and their GCD is 1. So he's replacing this 2 with 1. And finally, using the fourth operation, he's picking these two numbers. And since the GCD is 1, he's replacing the 4 with 1. So we can see the array has all the elements equal to 1. And we used total 4 moves. So the output will be 4. And we can prove that this is the minimum possible value for this input, because the array itself contains only 4 numbers. So we require at least 4 moves. Now let's look at the second input. We have 2, 10, 6, and 14. So suppose if I take GCD of these two numbers, it's 2. So let me replace this 10 with 2. And then if I take GCD of these two numbers, it's again 2. Let me replace this 14 with 2. Then if I take GCD of these two numbers, it's again 2. Let me replace the 6 with 2. So we can see after this, we can't transform the array further. So if we take GCD of these two numbers, the GCD again is equal to 2. So the array doesn't change. So we can see that no matter what we do, we can't reach all ones in this array. So that's why for this input, the answer is minus 1. So the constraints, we have the array size is from 2 to 50, which is pretty small. And the array elements can range from 1 to 10 power 6. Now let's go over the approach. So one observation we can make is, if we take GCD of any number with 1, the GCD is always equal to 1. So using this, suppose in your array, you have the values like 2, 7, 6, 1, 5, 4. So the array size is 6. And in this array, you can see you have a 1. So using this 1, you can transform all the other numbers to 1, because when you take GCD of any number with 1, you get the result as 1. So I have a 1 here. I'll take GCD of these two numbers and transform this 6 to 1 using one operation. Then maybe I'll pick these two numbers and transform this 5 to 1. And since this is a 1 now, I'll pick these two numbers and transform this 4 to 1. So we can say that in the array, if we have at least a single 1, then the answer will be equal to the number of elements which is not equal to 1. So we can say if there's at least one occurrence of 1 present in the array, then answer will be simply n minus count of the ones in the array. So suppose we have another 1 here. So in this case, the array size is 7. So 7 minus count of 1. 1 is present 2 times. Sorry, this is 2. So total we require 5 moves to transform this, and this numbers to 1. And this is the minimum numbers possible. So this is the first observation. Now let's see a case where we don't have a 1 present in our array. So which is 2, 6, 3, and 4. So in this case, our first goal is to produce a 1 in this array. So suppose after doing few operations, I'm able to produce a single 1 in this array. Now using this single 1, like we discussed in the previous approach, I can convert the remaining rest of the elements to 1. So the rest of the elements is equal to n minus 1. So from this, what I can say is I somehow need to convert, do few operations and convert, populate a single 1. And from that one, you can convert the entire array to 1. So now the question arises, how to find the least possible operations to populate a single 1. So like before that, let's see whether if it's really possible to populate a single 1 in this array or not. So suppose we have the second input, which is 2, 10, 6, and 14. So if we take GCD of all these numbers, the GCD value will be 2. So since the GCD of all the numbers is not equal to 1, then no matter what operations we make, we can never achieve a value 1 in this array. So for this case, the answer is -1. But the same thing, if we look at the first input, we can see that GCD of 2, 6, 3, and 4. So GCD of the entire array is equal to 1. So that means after doing some operations, it is possible to populate a single 1, and using that one, the remaining array will be easily converted to 1. So now we need to know the minimum steps required to populate a single 1. So for that, let's just check all possible subarrays. So the first subarray is 2, starting at 2. So this number is not equal to 1. So let's move to the second subarray, which is 2, 6. So the GCD of this subarray is equal to 2 and it's not equal to 1. So we can't populate a 1 from this subarray. So let's move to the next subarray, which is 2, 6, and 3. So GCD of these three numbers is equal to 1. So that means when we take GCD of all these numbers, we can populate a single 1. And let's see how that happens. So first we have 2, 6, 3 in this subarray. So GCD of 2 and 6 is 2. So let's update this as 2. So this is the first step. After this, we take these two numbers and take the GCD. And GCD of 2 and 3 is 1. So we'll update maybe this value to 1. So in the next operation, we are able to successfully populate a single 1. So from this, we can see that we have a subarray of size 3. So in this subarray, we need to perform 3 minus 1 number of operations to populate a single 1. So suppose our subarray is of length x, then we need to perform x minus 1 number of operations to populate a single 1. So let x minus 1 steps is required to populate a single 1. And once you have a single 1 in this array, using this one, you can convert the remaining n minus 1 elements also to 1. So your total number of steps will be the subarray size -1 plus the total array size -1. So in this example, it is 3 minus 1 plus 4 minus 1, which is 2 plus 3 equal to 5. But we can see that 5 is not the optimal answer. We can convert all the array elements into 1 in only 4 steps. So that means the subarray we have chosen is not the optimal one. So that is the reason why we check for all possible subarrays. Uh, all possible subarrays having a GCD1, we check this formula and take the minimum value of it. So let's quickly check which subarray is giving us the actual answer. So we have 2, 6, 3, and 4. So in this, if we pick this subarray of length 2, we can see that the GCD of this subarray is 1. So the total number of operations is the subarray size minus 1 plus the array size minus 1. So subarray size is 2, so 2 minus 1 plus array size 4, 4 minus 1, which is 1 plus 3 equal to 4. And 4 is our answer. So to summarize the approach, in the array, if we have at least a single one, then the answer will be simply equal to the array size minus the count of the ones. And if we don't have any ones in the array, then we iterate on all possible subarrays with who have a GCD equal to 1, and we try to minimize this term. Now let's quickly code the approach. So let me just take a count variable to count the number of ones and also the array length. If my number equal to 1, then count plus plus. So if count is greater than 0, that means if there's at least a single occurrence of 1, then we directly return answer equal to n minus count. So if it's not the case, then we have to check for all possible subarrays. So suppose we have the array like this: 2, 1, 4, 3, index 0, index 1, index 2, index 3. So first subarray is starting at index 0, ending at index 0. And the second subarray is starting at index 0, ending at 1, then 0, 2, then 0, 3. So these are all the subarrays starting at index 0. Then we proceed to check all the subarrays starting at index 1. So starting at 1, ending at 1, starting at 1, ending at 2, starting at 1, ending at 3, and so on. So first let's iterate on the starting point, I equal to 0, less than n minus 1. Now let's iterate on the ending point. So the ending point will start from j equal to I plus 1 and j less than nj plus plus. So here we are only considering two length subarrays because we are sure that there is no one in the array. So our subarray is starting from in I and ending at index j. So we need to take GCD of all the elements in this range. So let me just take a GCD variable and initially let's assign it as nums of I. And whenever we find a new element, I'll update GCD equal to GCD of current GCD and the new number which is getting introduced. So the subarray keeps expanding. And at any point, if I find my GCD is equal to 1, then I can populate a single one. So let's just first find the subarray length equal to j minus I plus 1. So the subarray is from index I to index j. So the number of elements will be j minus I plus 1. And using our formula, we can say the count will be sub length minus 1 plus the n minus 1. So using this many steps, you are able to populate a single one. And using that single one, you will convert the rest of the n minus 1 elements to 1. So you have the count and you'll try to minimize this count. So let's also take a answer variable, integer dot max value. And whenever we find a new count, let's minimize it. Math dot min answer comma count. And at the end, we'll just return count. We'll just return answer. And we also have a special case where if you are not able to make all the elements equal to 1, you have to return -1. But in our current implementation, you will return integer.max value. So let me just verify it. Okay, I think before that we need to quickly fill this GCD function. And GCD b equal to 0, return a, otherwise return find GCD b a mod b. So this is the recursive way to find the GCD of two numbers. Yeah, so the case 1 passed, but the case 2, instead of returning a -1, it's returning the integer.max value. So we just need to make an extra check for that. If answer is equal to integer.max value, that means answer never got updated. So that means we cannot convert the array into all ones. And we return -1. Otherwise, we just return the answer. We submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, here we are running a loop of order of n, and inside after that we are iterating on all possible subarrays. So we have total of n square subarrays. So these two loops complexity is n square, and inside that we are finding GCD of the numbers, and the complexity of the GCD will be log of the value. So the total time complexity will be order of n square into log nums of I. And coming to the space complexity, it is constant, since we are not creating any arrays, but only initializing few variables. I also have the code in Python if anyone wants to view it. I'll add this in the description as well. And let's catch up in the next video.